Hi everybody. If you're watching this video, then you have a brain. And that brain of yours loves patterns. Seriously. Like if I put up the number 2 and then the number 4 followed by 6 and then 8, you can't not be thinking about the number 10. How about if I show you a triangle followed by a square and then a pentagon and then a hexagon? You're thinking, what do they call that thing with the 7 sides again? And I have absolutely no idea. How about this pattern? 2, and then 4, and then 8, and then 16. You're thinking about the number 32, right? Well, today I'd like to show you an example where the next number in the sequence is 31. What? I know, right? I'd like to introduce you to Moser's circle. Take a circle and place 2 distinct points anywhere on that circle and draw the line between them. This divides the circle into 2 distinct regions, and the first number in our sequence is 2. Adding a third point and drawing the lines between this point and the other 2 points divides the circle into 4 distinct regions, so the second number in our sequence is 4. We continue by adding a 4th point to the edge of the circle and drawing lines to the first 3 points. And now we see that there are 8 distinct regions. Add a 5th point to the circle and draw lines to the first 4 points. And now there are 16 distinct regions. It is worth pointing out here that I'm being careful to make sure that no 3 lines intersect at the same point, since that would eliminate one of the regions. So far, we have a very nice pattern describing the number of regions: 2, 4, 8, 16. And it would seem obvious at this point that the pattern would continue. Let's try it. Adding a 6th point and connecting all the lines produces 31 regions. That's right, the next number in the sequence is 31. And it turns out that the nice pattern we were creating totally breaks down at this point. If we add a 7th point and draw all the connecting lines, we get 57 regions. This, of course, is a great example of why we have to be careful about patterns. Once we see a pattern start, there is no guarantee that that pattern is going to continue. It turns out that the actual pattern for the number of regions created by Moser's circle is given by the formula n choose 4 plus n choose 2 plus 1, which can be simplified to this 4th degree polynomial, and the actual sequence is nothing like what we expected it to be. Please see the video description for links for more information about Leo Moser, the person who came up with Moser's circle, as well as an absolutely amazing video by 3 Blue 1 Brown, where not only does he show where the formula for the number of regions comes from, but also gives a fairly intuitive description that uses Pascal's triangle. Again, thanks for taking the time to watch this, and I will see you in the next video.